We are now going to start Chapter 7. The first lesson in Chapter 7 is all about dilations. And dilations are ways that we make an image bigger or smaller. Okay, we're always going to be looking at a scale factor. The scale factor is going to be represented by the letter K. And it's going to change the pre-image. The pre-image is the original. So pre-image, we're talking about the original figure. And it's going to create a new image, and we're just going to call it the image. So the image is after something was done to it. It's just called the image. Okay, so this is after the dilation. So those are the two terms, pre-image and image. In this first example here, we have our center, which is O. We have our pre-image, the original, ABC, and this happens to be a triangle, and it just has the letters A, B, C on there. So I can say that triangle ABC is the pre-image. And then here's how I know that this bigger one is the new image. On your paper, hopefully it's a little bit easier to see, but you will see these marks here. And we talked about these marks last semester when we did transformations around the XY axis, and that's prime, right? So this tells me that something was done to the original figure. So this second one is actually triangle A prime, B prime, C prime. This is the image, okay? And I know that because of those markings, the prime markings. And in this case, we went from a smaller triangle to a bigger triangle. But this is how I would differentiate between the two. Which one was the original, which one's the new one after the dilation. And it's, again, based on those primes, the markings next to the letters. So there's two types of dilations that we're going to be looking at. We have reduction and enlargement. So for a reduction, this is a scale factor between 0 and 1, not including 0, not including 1. So the scale factor could be a decimal. It's either going to be a decimal or fraction smaller than 1. Okay, so just because it is a decimal or just because it is a fraction, it doesn't automatically mean it's a reduction. Okay, it has to be less than 1. So I'm talking maybe it's 0.5, or we write it as 1/2. Both of those numbers are less than 1. Therefore, they would be representing a reduction. Reduction means small. It becomes smaller. For an enlargement, this is anything bigger than 1. Okay, so literally just any number greater than 1. Now, it doesn't always have to be a whole number. Like it could be 2, or it could also be given to me as like 3/2. Okay, so 3/2 is a fraction, yes, but if I were to put that in the calculator, 3 divided by 2, that comes out to 1.5. So it's a fraction, but it's technically bigger than 1. It's a value bigger than 1. So that's why it would be considered an enlargement. A side note that I want to add on here is that if my K, my scale factor, is equal to 1, nothing is going to happen to the pre-image, because think about what happens when you multiply anything times 1. Okay, you get the exact same thing. So if a scale factor is equal to 1, nothing's happening to my pre-image. It's the exact same thing. It's not becoming smaller or bigger in any way. So here is an example of a reduction. It's a little bit easier to see since I have color here. But again, we're going from our original pre-image. I know this is the pre-image because when I'm looking at the letters, they don't have the prime next to them. Okay, and then when I compare it to the P prime, Q prime, R prime, for example, this one's getting smaller. So I know this is the new one because it has the prime. So it's going down, it's reducing. Now, you can look at it and say that it's a reduction, but mathematically, here's what you would do, okay? You were always going to compare the prime in the numerator over the non-prime in the denominator. Or in other words, you're always going to do the image, the new one, over the pre-image, the old one. So however you want to write it, new over old, pre-image, image over pre-image, prime over non-prime, however you want to think of it. These are the same things. Here's how you are going to compare it. So in this example, I know it's going to be a reduction, so my number needs to be less than 1. I'm specifically looking at C prime, or just prime here. You always want to go from the center if the picture looks like this. I'm going to show you 2 different ways that our picture could look like. If it looks like this, you're going to go from the center to the prime value, so that's 3. That goes in the numerator. That's the new one. And then in the denominator, it's the old picture. I know it's the old picture because it doesn't have those markings, right? There's no markings on the P. So I start from the center and I go all the way to my old image, and that is 6. So when I put the new over the old, 3 over 6, it gets me 1/2. And if you're not feeling super confident with reducing those fractions, you can just enter this in your calculator as 3 divided by 6, and that's going to give you 0.5. 0.5 is less than 1, which is why I know it's a reduction. Okay, so if the image looks like this, just compare the new over the old. Definitely use your calculator to determine if it's less than 1 if you're not feeling super confident, and then decide whether it's a reduction or enlargement. The second example is showing me an enlargement, and again, I'm going to go from the center to my new image. I know this is the new one because it has the prime. So from the center to the new, that's 5. So 5 goes in the numerator over the old. The old doesn't have any markings, so I'm going from the center to the old. That's 2. That goes at the bottom. So again, new over old, or image over pre-image. And if you're looking at this and you're like, I don't know if that's bigger than 1. Again, just put it in the calculator. 5 divided by 2 gives me 2.5. So this is bigger than 1, right? So that's why it's an enlargement. That's why it's an enlargement. If you're looking at it, right, it makes sense that the little triangle became a bigger triangle, so it got bigger, it enlarged. So visually, that's how you can tell it's an enlargement. Mathematically, you're looking at the scale factor. How much more did it grow? So let's take a moment, try to see if you can figure out these two. We're going to go ahead and pause the video, and you're going to try. First, you're going to tell me what is the scale factor, and remember that's represented by the letter K. And then I want you to tell me whether this means it's a reduction or an enlargement. So let's pause here. Okay, let's see how we did. So remember, we're always going to do the new image over the pre-image. So I'm doing the prime over the non-prime. And I'm just going to use the one letter here. So my prime, I go from the center to the prime, that is 2. And then I'm going to do the non-prime, so from the center all the way over to P, that's 3. So that's going to be your scale factor, 2 over 3. Or if you put it in the calculator, it's going to give you like 666 repeating. Because this is less than 1, this is a reduction. So we want both things here, the scale factor, and whether it's a reduction or an enlargement. For the second one, again, we're doing the prime, which is, in this case, from the center all the way to P, that's 2, over the non-prime, the original pre-image, it's just 1. So if I put that in the calculator, it's just 2, or 2 over 1. And because 2 is bigger than 1, this is an enlargement. Okay? So now we're going to talk about what happens when it's given to us in the coordinate plane. Essentially, what we're going to do is we're going to have an image, a pre-image, and we are either going to have to plot it or it's going to be plotted for us. And then we're going to be given a scale factor. And this scale factor It's going to tell me to either make the pre-image bigger or smaller. So what you're going to do is take the scale factor and you're going to multiply your x and y by the scale factor. Okay. So looking at the scale factor, you should know if it's bigger than 1, my image should be getting bigger. If it is smaller than 1, it should be getting smaller. So if when you're plotting it, it's not quite, doing what it's supposed to be doing, then go back and check your math. So here we have our first example. And in this example, we have our pre-image. There's A, there's B, there's C, and D, okay? So what I'm going to do first is I'm going to write down my pre-image coordinate points. So A is at the point 2, 2. So this is my origin. A is at 1, 2, 1, 2. There it is. So 2, 2. B is at 6, 2. C is at 6, 4. And D is at 2, 4. Okay, so again, I'm just figuring out where these points are. So that's my original. In the blue, again, I know this because it doesn't have primes. Now I'm going to look at my image, my new one, and the new one has those primes. So my new A value is here at, and I'm going to label it A prime, is at 1, 1. My B prime is at 3, 1. C prime is at 3, 2. And D prime is at 1, 2. Okay, so how did we get there? How do I go from 2, 2 to 1, 1? By multiplying it by something. That's what you're trying to figure out, okay? So remember that we're going to find the scale factor. We can find the scale factor by doing the new over the old or the image over the pre-image. And just pick a value. Pick an x or pick a y. Doesn't matter. I'm just going to go with my x's. Okay, I'm just going to pick my x's from each one. So for A, the x value is 1, and it was 2. So my image goes on top, and then my denominator is going to be my pre-image, which is 2. So this should be the scale factor, but I'm going to try that with all of them just to double check. So if I go down to B, my x value for the new one is 3, and my y value was 6. So when I reduce that, it reduces to the same thing, the 1/2. It should. Okay, otherwise you're doing it wrong. So there, I do it again. 3 and 6 reduces to 1/2. 1 and 2 is just 1/2. Perfect. So your scale factor is 1/2, which means this is a reduction. And I'm looking at it, and the blue image was bigger than the red one. So yes, it did get smaller. That's why it is a reduction. Okay. So this is just me showing you how we would find the scale factor. Now, in these next two examples, what you're actually going to do is you're going to use the scale factor to find the new coordinate points. So here, number 3 is asking me to take this pre-image and apply a scale factor of 2 and create a new image, okay? So my first step that I like to do is write down my coordinate points for the original. So R is originally at 1, 1. P is originally at 3, 5. Q is at 4, 0. Okay? A scale factor of 2 means I'm going to multiply everything by 2. Everything. So that's going to create a new point. This is going to create a new R prime. If I multiply 1 times 2, I get 2. And 1 times 2, I get 2. For P, 3 times 2 is 6. 5 times 2 is 10. And for Q, 4 times 2 is 8. 0 times 2 is 0. So now I am going to graph or plot my new points. R prime, 2, 2, that puts me right here. R prime. P prime is at 6, 10, so 2, 4, 6, up 10, 2, 4, 6. We're going to go off 8, 10. We're going to approximate right over here. That's P prime. And then Q prime is 8, 0, so that would put me over here, Q prime. We're going to go ahead and connect our dots. Do your best to make it a straight line, and that is our new image. A few things to go back and double check you're doing it right. Scale factor bigger than 1 means it's getting bigger. Is my new picture bigger than the original? Yep, that's a good sign. It means I'm doing it right. Okay, so I do want to see your new points. I want to see your new image when you are given the scale factor. Okay, and last example here. This time we have a scale factor of 1/3. So this tells me my picture is going to get smaller. That's a reduction. Okay, so before I even do any math, this is my hint. It needs to be getting smaller. First step that I like to do is write down where my points are. D is at -5, 4. E is at 3, 2. F is at 5, -2. And G is at -3, -4. Now, I purposely gave you a fraction one because people don't like fractions, but we're going to deal with it. So D prime. How do you multiply a whole number times a fraction? Well, if you have a calculator, we're going to take the -5. We're going to multiply it, and then you're going to go, our scale factor is 1/3, so you're going to click the 1, and then the ABC button, and then the 3, okay? Or you really can just put the 2 together, so like -5 times 1/3 is just going to be -5 in the numerator, 3 in the denominator. However you want to do that, I need you to feel comfortable multiplying the fractions. If when you do that in the calculator, it's not giving you an improper fraction, you can also go to the second button and then click the ABC button again. And then it'll give you the improper fraction of -5/3. Okay? So I'm going to quickly show these. Please make sure you're taking the time to actually put this in the calculator. Because, for example, here, when I do 3 times the 1/3 in my calculator, it should give me 1. Okay, so pause the video if you need to, and make sure that you are able to get these numbers on your own in the calculator in case you come across a fraction in a later example. Okay, so here are my fraction answers, and now I have to plot these. So you may need to, anyway, turn these into decimals. Some of you are able to plot this without needing to turn these into decimals, but you can turn them into decimals if that's helpful to you. So -5/3 is going to be like -1.67, and then 4/3 is +1.3. Okay, so I'm just turning these into decimals so I know where approximately I'm going to be plotting 1.6 and -0.6 and -1. Okay, so I'm going to plot these. -1.6, I'm going to go left 1 and a little bit, up 1 and a little bit, so D is right there, D prime. Next one, right 1, up a little bit, that's E prime. And then right 1 and a little bit more down, like halfway-ish. That's going to be F. We're approximating here because they are decimals, and I totally get that. And this is going to be G prime. There is my new image. I did get smaller. That's good. I wanted it to get smaller because my scale factor was a fraction less than 1, which means it is a reduction.